Today is our first day with geometry proofs. So first we need to make sure we're clear on some differences between our symbolism. So what is the difference between AB, where it's got the little line over the top, and AB, where there's no line over the top? So AB, where it's got the line over the top, is referring to the physical segment AB. But if we don't see the line over the top, it means the measurement of AB. So in this case, it's talking about the 4 centimeters. So when you're giving an actual measurement, you don't put the line over the name. And we have the same thing happening with angles. So if it just has angle B versus the little m in front of it, which means measure of angle B, there's a difference. So if it doesn't have the m in front of it, it's referring to the physical angle B. So it's talking about this physical angle, whereas when it has the little m, that means the measurement of angle B. And in this case, the measure of angle B is 75 degrees. So you're going to see some properties that we already saw with algebra proofs. So for segment congruence, we still have reflexive property. So for any segment AB is congruent to segment AB. We have the symmetric property that says if segment AB is congruent to segment CD, then I can switch the two sides around and say that segment CD is congruent to segment AB. Remember, when you're doing a proof, you have to make sure that the order that you have your final answer in is the same order that you were asked for the statement you were supposed to prove. And then we have transitive property. So what transitive property says is if segment AB is congruent to segment CD and CD is congruent to EF, then AB is congruent to EF. So again, what you're looking at on transitive property is the two middle sections match. So CD matches CD. You take out that matching part and then you put together the two pieces that are left. And we have the same properties working for angle congruence. So reflexive property still works. So angle A is congruent to angle A. And symmetric property, so we can still switch the order around and say that angle B is congruent to angle A. And transitive property also works. So if angle A is congruent to angle B and angle B is congruent to angle C, then you take out that matching part of angle B and you put angle A and angle C together. So we have talked about theorems last lesson, and today we're also going to have postulates. So a postulate is a rule that is accepted as true without having to prove it. So we have the segment addition postulate. So if B lies between A and C on segment AC, then AB plus BC equals AC. So it's basically saying that you can add the pieces together to make the entire segment. So you can use that to solve for missing values. So for example, here they want us to find the length of RT, and we know that RS is 5 and ST is 30. So that means I can add 5n and 30 together and set that equal to the 9n minus 5. And then you could go through and do your algebra to solve it. So I personally would start by subtracting 5n from both sides. And then I would add 5 to get rid of the minus 5. And then divide by 4 to get rid of that multiplication by 4. But then, now that I know that n is 8.75, that's not what I was asked to find. I was asked to find the length of segment RT, so I need to substitute that 8.75 in for the n. So you get 73.75. Then we also have the angle addition postulate. So if D lies on the interior of ABC, then measure of angle ABD plus measure of angle DBC equals the measure of angle ABC. So again, it's just saying you can add the pieces of the angle together to make the entire angle. So here on example 2, we are given that angle ABD is 107, and they want us to find the measure of angle ABC. So I can add the 4x plus 2 together with the 3x minus 7 and set that equal to 107. So then when you add your like terms together, you would have 7x from adding the 4x and the 3x. And you can add the 2 and the negative 7 together and get negative 5. And then add 5 to both sides. and then you could divide by 7 and get that x is 16. But again, that's not what I was asked to find. I was asked to find the measure of angle ABC. So I need to substitute that 16 in for my x and work it out. So the measure of angle ABC is 66 degrees. All right, so some reasons that we use when we're doing proofs are going to be definitions. So the definition of congruent segments are line segments that have the same length. And the definition of congruent angles are angles that have the same measure. We also use the definition of midpoint, which is a point that divides a segment into two congruent segments. So for example, if I have this segment AC, and I'm told that B is the midpoint, that means that AB is congruent to BC. So, like everyone else, I struggled through proofs when I was first learning how to do them. So I have some hints for you from my years of experience with doing proofs. So first hint is identify the proven given statements. Use definitions, postulates, and proven theorems as your reasons. Remember to give a reason for the last statement. The number of statements varies, and even from person to person, you may find a different way to prove a statement than I found or your shoulder partner found. One thing that really helps me with proofs is to think about what angles or segments I need to work into the proof and how to work them in. So if there's an angle or a segment that is in my final statement that I'm supposed to prove, but it's not in my given, I think about, well, what properties or theorems can I use to work that in? You also need to understand that you can't do operations such as addition, subtraction, etc., or substitution with congruence. You can only do it if you've changed it to be equations where it's equality. So for example 3, if the measure of angle 1 equals the measure of angle 5, and measure of angle 5 equals measure of angle 3, and you know that measure of angle 1 is 103, what is the measure of angle 3 and how do you know? So I can use transitive properties. So measure of angle 5 has to be the same as measure of angle 5. So if those two match, then I can take that part out and put the measure of angle 1 equal the measure of angle 3 by transitive property. And then because those are equal to each other, I can substitute in because I already know that the measure of angle 1 is 103. All right, so here is our first formal geometry proof. So we are given that angle 1 is congruent to angle 5, and angle 5 is congruent to angle 3, and the measure of angle 1 is 103 degrees. And we want to prove that the measure of angle 3 is also 103 degrees. So we are given that the measure of angle 1, that angle 1 is congruent to angle 5, and angle 5 is congruent to angle 3. We're also given that measure of angle 1 is 103. Some people, when they do their proofs, they put the given all together in one big statement, and sometimes you'll see them separated out, and sometimes you'll even see where they give part of the given as statement 1, and then they give the other part of the given later in the proof when they actually need it. I personally like to give all of the given at the beginning. All right, and then if we take statement 1, and we see that we've got this matching part with the angle 5 and take that part out and put together the angle 1 and angle 3, that's transitive property that says if the middles match, you can take the middles out and put the ends together. And then I want to actually prove what an angle measurement is, not congruent. So anytime I need to change from congruent to equal or equal to congruence, that's just the definition of congruent segments. Or, I'm sorry, that should say congruent angles, not segments there. And then I can use substitution because I know that the measure of angle 1 is 103. I can replace this statement on step 4 where it's got measure of angle 1. I can replace that with 103, which is just substitution. But then this isn't in the right order. This does not match what I was asked to prove. So to be able to switch those two pieces around, I'm going to use the symmetric property. All right, so example number 5, we know that JK is congruent to MN and that segment PQ is congruent to MN, and we need to prove that JK is congruent to PQ. So we've got our given, And again, I personally like to give all of the given at once. And then we can use symmetric property because the MNs are matching, and that lets us put the JK and the PQ together. And then I don't really have it in the right order. Sorry, no, it's not that I don't have it in the right order. It's that I'm using transitive property again. So I'm putting these two pieces, saying that these two pieces match. Okay, I'm sorry, I messed up. I used symmetric property first. I was thinking I used transitive first. But actually what I did is I took this statement and switched the order around because the order was not right for transitive. So see how it's the end of this one, but it's the end of that one. So I had to switch this order around and make it say MN is congruent to PQ so that I could use so that I could use transitive property. So now these pieces match and I can put those two together. So I apologize, I made a mistake there. All right, so then on example 6, we know that DG is 6 and GF is 8. Oh my gosh, I messed up again. We know that DG is 8 and GF is 8 and that GF is congruent to EF, and we need to prove that DG equals EF. So we have our given that DG is 8, GF is 8, and also that GF is congruent to EF. So again, we have to make sure that if we're trying to do things with equality, that we change it from congruent to equal. So I can say that GF is equal to EF by definition of congruent statements or segments. And then I can use substitution. So if DG and GF both equal 8, then they have to equal each other. So DG equals GF by substitution. And then DG equals EF by the transitive property. So the end of this statement matches the beginning of this statement, so I can put those two together. And that's what I was asked to prove. So I don't really need 6 steps on this one. All right, so next we are given that AB equals DE. So AB equals DE. And BC equals CD, and we're also asked to prove that C is the midpoint of AE. So we have our given, and this is an example where you're going to see the given is broken up into 2 different parts, and I just wanted you to see examples of different ways to do proofs. All right, so one thing that I would think about is the fact that I need to work into this AC and CE because I'm asked to prove that C is the midpoint of AE, and I don't have those in my proof yet. So I'm going to be thinking about how can I work AC and CE into this proof. So I could use segment addition postulate to work that in because I know that AB plus BC has to equal AC, and that's by segment addition postulate. And then also CD plus DE has to equal CE. And again, that's segment addition postulate. And then I'm needing to think about the fact that I need to work those into the same statement because I'm needing to show that AC equals CE. So in order to do that, I'm going to use substitution. So I know that AB plus BC equals AC, and also that CD plus DE equals CE. So I'm looking for how I can put those together with substitution. So what I'm doing is I'm replacing things with what they're equal to. I already know that DE and CD are equal to the same thing.